first of all, okay, in the last lecture we have find out the z transformation of xn is equal to cos omega naught n un. So by using the Euler identity, we have separate, we have find out the z transformation of this signal. Okay, so we have written it as the cos omega naught n is equal to 1 by 2 e the raised to power j omega naught n, okay, plus e the raised to power minus j omega naught n. We have written a cos omega naught n as the, according to the Euler identity, cos omega naught n plus e the raised to power minus j omega naught n. Okay, so then we have written as this as the e the raised to power j omega naught n plus 1 by 2 e the raised to power minus j omega naught n. Okay, so we have written this is my x n and u n. When we have solved this z transformation of this signal, we have applied the formula, simple formula, that alpha power n u n is equal to z upon z minus alpha, and its ROC is the mod z is greater than alpha. Okay, so by using this identity, we have find out the z transformation of this signal. And in the last, you have students, you have find out that x z is equal to 1 by 2 like z upon z minus e the raised to power j omega naught plus z upon z minus e the raised to minus z omega naught. We have find out this solution. Then I told you that you must solve this equation, and in the last you are getting the answer like, okay, you must solve this, simply take the LCM or simply solve this equation of this equation, and you may simplify this equation and you may must find out the solution of this equation. And I have told you that the solution of this equation is in the form like a we can write down the simple solution of this term into the xz is equal to z square minus z cos omega naught. Okay, so in the numerator part we are having z square minus z cos omega naught, upon denominator we are having the z square minus 2z cos omega naught plus 1. Okay, so we have simplified this expression into this term. Okay, so how many students have solved this expression and find out that the solution of z transformation of cos omega naught un is answer is this one? Because in the paper you have to write this equation, and when we are solving the next numerical and when we are applying the properties of the z transformation, we are using this formula of the xz. Okay, so can I solve this, student? Can I solve this expression, or you will solve by your own?
सर सॉल्व कर दीजिए
Sir, please.
Okay, I will solve this expression. Okay, so we are having when we have applied the formula of the when we have applied the formula of this when we applied the formula of this z transformation, we are getting this solution. Now I will take the LCM of xz is equal to 1 by 2. Okay, So this is the z minus e the raised to minus j omega naught. This is also z minus e the raised to power omega naught. So in the denominator we are having z minus e the raised to power j omega naught. Here we are having z minus e the raised to power j omega naught. And upper one we are having z. So this one is multiplied with this one, z minus e the raised to power minus j omega naught. Okay. So next we are having a plus sign here, z plus, oh sorry, z minus e the raised to power j omega naught. Okay, we are having this equation. Okay, students. Any doubt regarding this equation? This is clear to everyone?
Yes, sir.
Yes, sir.
Okay. So I think this equation is clear to everyone. Now,
Yes, sir.
uh, any doubt regarding this equation? How I have written this equation? It is clear to everyone?
Yes, sir.
Okay. So upper one is the z minus e the raised to power j omega naught. Basically, this part we are having multiplied with z. Okay, z minus e the raised to power j omega naught. I think it is not in your screen. Okay, so we are having this term. Now I will do the multiplication in the denominator. We are having z square minus z e the raised to power minus j omega naught. Okay, then e the raised to power minus j omega naught z, then plus e the raised to power j omega naught e the raised to power minus j omega naught. We are having this term in the denominator. Okay. So any doubt to any student regarding this? So you have done these steps or not?
Yes, sir.
Yes, sir.
Okay. So we are
Yes, sir.
getting this term in the denominator. Okay.
Yes,
So
sir.
upper part I am solving 1 by 2. I have written separate. This is the z square minus z e the raised to power j omega naught plus z square minus z e the raised to power j, sorry, this is the plus one, j omega naught. We are getting this term. Okay. So I am again simplifying this equation. So here I will apply the Euler identities. Okay. Again, here I am applying the Euler identities. You may aware about the Euler identities. We are applying the different Euler identities in the questions. So I will simplify again. I am writing this 1 by 2. Okay. Denominator term. First of all, denominator term. We are solving the denominator term. Okay. So denominator term, why I will write z square, then minus, I will take a z term here common, and I am multiplying it with the 2 and dividing it by the 2. Okay. Multiplying with the 2, this is the 2z, and dividing it by the 1 by 2 here. Okay. So inside the bracket we are having e minus j omega naught minus e the raised to power j omega naught. Okay. So plus this term is equal to 1. Okay. Okay, students. Any doubt to anyone regarding this?
No, sir.
Okay.
No, sir.
So this is the plus one. We have written this term. And the like in your numerator part, I am solving the numerator part. This is the z square. This is also z square. This is the 2z square. Okay. I have written it as the 2z square. Then it is a 2z square. Then I will take this term with this term. Okay, this is the minus z. Okay, again I am taking common z from these two equation, and I'm multiplying this with the 2, and I am writing 1 by 2 e the raised to power minus j omega naught minus e the raised to power j omega naught. Okay, I am having this term. This one is clear to everyone?
Yes, sir.
Okay, Prachi, Harkirat,
हाँ जी सर क्लियर है
Krishna, Karan Sharma, Jyotisna, Milan Kumar.
Yes, sir.
Yes,
Clear.
sir.
Okay, okay, students. So uh, now I am applying here the Euler identity. I will cancel this 2 with this 2. I am not canceling. Okay, we have this 2 and this 1 by 2. Okay, don't cancel this 2 and 2. Okay, so what is the Euler identity? Basically, if we are having a like a e the raised to power j theta. Okay, so like if you are having a e the raised to power j theta. Okay, if I am talking about I am having a formula of the e the raised to power j theta. This thing is equal to cos theta plus j sine theta. Okay, if I am talking about e the raised to minus j theta, this is the cos theta minus j sine theta. These are the two Euler identities. Basically we are using these two Euler identities. So if I want cos theta term, okay, what I will do, I will simply add these two terms. I will getting the e the raised to power j theta plus e the raised to minus j theta is equal to 2 cos theta, like this one. Okay, we are getting the values of the cos theta. Similarly, we will find out the value of the sine theta. Okay, so we are having these two terms here present here, and these two terms are present here. Okay, so what I will do now, I will apply the Euler identities here. Okay, I will apply the Euler identities in this equations. So you directly apply the Euler identities. What is the Euler identity? This one. So this function is equal to my cos theta function. Okay, this function is equal to my cos omega naught. So this is the equal to the 1 by 2 z square minus z cos, this is 2z, this term is equal to cos omega naught. Okay, and in the denominator we are having z square minus 2z. This term, this one term is equal to the cos omega naught plus 1. Okay, take the 2 common from the numerator, and this will cancel out with this 2. If I will take the common, this 2 I will take the common outside, this 2 will cancel out, and you are getting with the z square minus z cos omega naught upon z square minus 2z cos omega naught plus 1. We are getting this answer. Okay, now any doubt to any student regarding this?
No, sir.
No, sir.
It is clear to everyone?
Yes, sir.
हेलो सर.
हाँ जी बेटा.
सर आइलर आइडेंटिटी के थी, उसको यूज कैसे किया वो क्लियर नहीं होगा.
अभी बताता हूँ बेटा, ठीक है. So put here plus sign is there. Simple, you are having here z minus z e the raised to minus j omega naught. Here we are having a minus z e the raised to j omega naught. If I will take a minus z common, if I will take these two terms and I will take minus z common here. Okay, if I will write down the minus z common, these two, this is negative term, this is negative term, these two term will become a positive term. Okay, so this again in the denominator part I have taken this limit and this one. Okay, again take a minus z common in the denominator, you will e the raised to minus j omega naught plus e the raised to minus j omega naught. If you are having this term, In the denominator, this is equal to the cos omega naught. Okay. Euler identity, how to apply the Euler identity in this question, I am again explaining to you. Okay. So I will explain you here Euler identity, beta. This one is clear to you or not?
Yes, sir, clear.
Euler identity बता देता हूँ अभी बेटा. Okay. Like a Euler identity, we are having a e to the raised to power j theta. This thing is equal to cos theta plus j sin theta. E to the raised to power minus j theta, you are having a cos theta minus j sin theta. Okay. If I want a cos term, what I will do, I will simply add these two terms. Okay. Cos theta, I will add these two terms. And when I will adding these two terms, I am getting e to the raised to power j theta plus e to the raised to power minus j theta is equal to 2 cos theta. Okay. You are getting this. If you will add these two equations, you are getting this term. Okay. If I will write down this 1 by 2, if you are having this term, like that is equal to the cos theta. So in the denominator, we are having 1 by 2 e to the raised to minus j omega naught plus e to the raised to j omega naught. Here in the numerator, we are having 1 by 2 e to the raised to minus j omega naught plus e raised to j omega naught. So this term will become a cos omega naught, and in the denominator, we are having a cos omega naught. Now it is clear to you or not?
Yes, sir, clear. Thank you.
Any student having any doubt regarding this numerical?
No, sir.
Okay. Okay, students. Next question is for you. Okay, you simply solve the like it is today's tutorial. Okay, and today's tutorial question number 1. You simply solve this tutorial and send me the PDF in the DSP group. Question first of the tutorial is the you have to find out the Z transformation of sine omega naught n un. Okay, this is equal to xn. This is the first question. I will give you the 4 question in today's tutorial, and you have to solve that 4 question and send me the PDF in the DSP group. Okay, so this is the first question. Sine omega naught n un is equal to xn. Okay, so as I have solved the question of cos omega naught n un, you simply solve the Z transformation of sine omega naught n un xn, and send me the this tutorial in your DSP group. Okay, so I think this one is clear to everyone. Now I am moving toward the properties of the Z transformation. That is the second property of the Z transformation. That is the like a scaling property of the Z transformation. Okay, students, today we will do the scaling property of the Z transformation. Then we will do the numerical part of the scaling property of the Z transformation. So first one is the scaling property of Z transformation. Okay, so scaling property is saying that like if xn Z transformation is given by xz. Okay, means xn is given and x and z transformation is given by xz. Okay, then we will, if you are having a power n xn, then its z transformation is given by xz upon a. Okay, then if you are having a power n xn, then its z transformation is given by x z upon a. And in the first case, you are having the ROC like R1 is z, into R2. But in this case, the ROC is changing. That is the mod A R1 Z into mod A R2. Okay, we are having this term. ROC is also changing. Okay, this is the scaling property. So I will explain you this scaling property. Means I will give you a one example. From that example you will understand what is the scaling property actually. Means we are having a UN. Okay, you everyone know that a z transformation of UN is the z upon z minus 1. Okay, and its ROC is the mod z is greater than 1. This we have done in the last lecture. UN z transformation is the z upon z minus 1, and ROC is the exterior part of the circle of radius 1, that is mod z is greater than 1. But if the question came like alpha the power n u n, find the z transformation of this signal. Okay, so simply I will told you that in the previous lecture ki if you are solving the numerical of the z transformation, it is lengthy, it is of 1 or 2 pages. But if you are applying the properties, you will find the like a question came in, find the z transformation of alpha power n u n. So simply you will solve this numerical in the 2 steps. Means you will say un z transformation is the z upon z minus 1 mod z is greater than 1, because this is the standard formula. But if the question came alpha the power n u n z transformation, then you simple say where it is the z in the xz, where you are having a z, replace z by z upon alpha. Okay, z upon alpha minus 1. Here you are having z upon alpha is greater than 1. Simply what you will do, simply you are having a z transformation of u and simply replaced z by z upon alpha. Means that is the z transformation of the alpha power n u n. So its z transformation is the z upon z minus alpha, and its ROC is the mod z is greater than alpha. Simply answer. Okay, so this one is clear to everyone or not? इसमें कोई
Yes, sir.
doubt?
No, sir.
No, sir.
It means if the question came like find the z transformation of alpha power n u n, you simply solve this numerical in the 2 steps. Okay, means you can say this is the standard formula, and alpha power n u n, simple applying this scaling property. Here you will write down by using scaling property. We are having replace z by z upon alpha. You are solve this numerical. Okay, क्वेश्चन ऐसे नहीं आता, क्वेश्चन ऐसे आता है, सिंपल सीधा क्वेश्चन 3 दी पावर n un. ओके, क्वेश्चन ऐसे आएगा xn is equal to 3 दी पावर n un. Find the z transformation of this signal. You simple say un z transformation is the z upon z minus alpha, mod z is greater than 1. 3 power n un z transformation is the replace z by 3, because here alpha is the z by 3, or you simply say that it is the z by 3. So it is the z upon z minus 3, and mod z is greater than 3. ROC is this one. ROC is the exterior part of the circle of radius 3. This thing is clear to everyone or not? Any doubt regarding this scaling property?
No, sir. No, sir.
कैसे यूज करना है? Means if you are a question came in the examination, you simply use these properties and solve the numerical with the 2 or 3 lines. Okay, I will give you a like a question of 2 or 3 question more. Okay, like question came in the examination. We know that like a z transformation of these standard signals are given. Okay, likewise we are having a you know that cos omega naught n un. And question came like alpha the power n xn is equal to, find the z transformation of this signal. Okay, this is the alpha power n cos omega naught n u n. Find the z transformation of this signal. You simply say that z transformation of cos omega naught n u n, the z transformation of this standard signal is equal to the, that is the z square minus z cos omega naught divided by z square minus z cos omega naught. Here it is the negative sign, 2z cos omega naught plus 1. Now what you will do, okay, you have to find out the z transformation of the alpha and cos omega naught and u n. What you will do, simple replace z by z upon alpha, because here we are having alpha power n. So you will simple say replace, okay, replace z by z upon alpha. In this equation you will getting z upon alpha square minus z upon alpha cos omega naught divided by z upon alpha square minus 2 z alpha cos omega naught plus 1. Okay, so you are having this solution. Simplify this solution, you will find out that its answer is the like z square minus a z cos omega naught divided by z square minus 2a z cos omega naught plus 1. This is your answer. Okay, ROC simple, that is the mod z is greater than alpha. Okay, a or alpha, you can write anything. I have written here alpha as this one. So this is the alpha, this is the alpha. Okay, scaling property. Any doubt to any student regarding the scaling property?
No, sir.
Means if the question came, you simple like you are having a, you know the z transformation of u and, okay, you are know the z transformation of cos omega naught, and you know the, these are the sin omega naught. And if the question came like alpha the power n, you know the z transformation of these standard signals, you simply replace uh, z by z upon alpha in that equation, and you can find out the z transformation of that signal. Okay, so I think this scaling property is clear to everyone. Okay, so moving toward the next property, that is the time shifting property. Okay, next one property is the time shifting property. I am again and again saying that students try to understand these equations, because with the try to understand these properties, because with the help of these properties you simply solve the numericals within the like a 3 or 4 steps. Otherwise you will solve the numerical with the 2 or 3 pages numerical. Okay, it is very difficult to solve the numerical of the z transformation without the help of these properties. Okay, so try to understand these properties. Next one we are having, that is the property is called the time shifting property. Okay, that is the very important property also. So next one property we are having, that is the time shifting property. Oh, sorry. Next, we are having a time shifting property. This property says that if x and z transformation is equal to the xz, okay, if x and z transformation is equal to the xz, then x n minus k means if there is a delay in the signal, okay, you are having a z transformation of xn is the xz, but if there is a delay in the signal, okay, then you will z transformation is given by the z minus k x z, okay, then its z transformation is given by the z minus k x z, okay. So what is this property indicate? Okay, again I am telling you, can I explain you with the help of the numerical, or I will give you a proof?
Sir, numerical sir करवा दो.
Okay, I will explain you with the help of the numerical. Okay, suppose in case you are know that a delta n is there. Okay, delta n means delta n graph is like this one. Here we are having n, here we are having minus n. This is the graph of delta n. Delta n is the one at n is equal to 0. Okay, means delta n की value क्या थी 1 for n is equal to 0 and 0 for otherwise. Okay, 0 for otherwise. Okay, if I am finding the z transformation of this signal, this is equal to summation n is equal to minus infinity to infinity x n z power minus n. Okay, now if I am putting xn is equal to delta n, my xn is equal to delta n, and delta n is the function that is having a single value, means this value is the one for n is equal to 0. Okay, means at n is equal to 0 amplitude is the one, otherwise at all other position its value is 0. So if I am putting here, then summation this is the n is equal to 0, means we will take only a single value n is equal to 0, delta n z power 0. Okay, so this value is the 1, z power is the 1, its z transformation is equal to the 1, means delta n z transformation is equal to 1. In the numericals, okay, you simply used the z transformation of these standard signal, means you know the z transformation of the delta n, you must know the z transformation of u, and you must know the z transformation of cos omega naught, and you must know the z transformation of the cos omega naught n u and sin omega naught n u and like this one. Okay, so you must know these values. Okay, so we will use these values directly. Okay, from here we have concluded delta and z transformation is the 1. Okay, but in the exam, like you face a question like find the z transformation of delta n minus 10. Okay, so what you will do? Okay, yeah, question came like n plus 10 delta n plus 100. Okay, question came like this one. So how to solve these kind of questions in the examination? We will solve these questions with the help of the time shifting properties. Okay, we will solve the question of these questions with the help of the time shifting property. And what is the time shifting property basically? Okay, so time shifting property saying that if x and z transformation is the xz, and x n minus k z transformation is the z minus k xz, this is basically the time shifting property, means if there is a delay, that is the z minus k xz. This is the basically time shifting property. And if you are having like advance of the signal xn plus k, then its z transformation is the its z transformation is given by z plus k x z. Okay, that is the x plus k Okay, x z. Okay, so I will give you the one or two, three questions here. Okay, how to solve the z transformation, how to apply this time shifting property. Okay, so now students see how to apply this time shifting property. You know that delta n z transformation is 1. U and z transformation is the z upon z minus 1. Mod z is greater than 1. Okay. So how to find out the z transformation? Question came like delta n minus 10. You simple say question came like this one, delta n minus 10. You simple say z transformation of delta n is the 1. So we have a delta n minus 10 by applying, you here write down, by applying time shifting property. Okay, time shifting property. Okay, you will simple write down the by applying the time shifting property. We are having property that if x n minus k is the z power minus k x z. Okay, so what we will do, delta n z transformation is 1, delta n minus 10 z transformation is the, you simple write down z minus 10, and z transformation of, you will write down here z transformation of x, z transformation of delta n. So z transformation of delta n is the 1, so answer is the z minus 10. This thing is clear to everyone or not? How I have written z minus 10? Karan
Yes.
Sharma.
Yes, sir.
Okay. Any doubt?
No, sir.
हाँ जी. हाँ हाँ. X z minus k x z. ये क्या है बेसिकली? दिस इज द z ट्रांसफॉर्मेशन ऑफ xn. ओके, xn की z ट्रांसफॉर्मेशन आपको मालूम ही है. इस केस में xn क्या है हमारे पास? डेल्टा n इज द 1. ओके, एंड द वैल्यू ऑफ द u and this I have written the standard formula. Okay, don't see this one. If we are having question delta n minus 10, okay, you know z transformation of delta n is the 1. Simply what we are having here, this thing is the, basically we are having a delay. Okay, so delta n minus 10 means delay of 10 units. You simply write down z minus k x z. Okay, so we are having formula this one, z minus k x z. Okay, this is the z transformation of the delta n. Okay, delta n z transformation is the simple. First of all, you will write down the delta n minus 10. We are having a delay of the 10 units. Okay, so we will write down here z minus 10. Okay, how many units are delay are here? We will simple write down z minus 10, and this is the xz. This is the z transformation of the delta n. This is the 1. So your answer is the z minus 10. That is the answer. 1 basically. The property is this one. Means if you are having a delay of the like a k units, it is z minus k x z. Okay, we will simply write down the z transformation of the delta n. Student, this is clear to you or not?
Yes, sir.
Any
Yes,
doubt
sir.
regarding this time shifting property?
No, sir.
No.
Okay, I will give you one more example of the time shifting property. From that, you will understand the what is the exact meaning of this time shifting property basically. Okay, so if you are having like a un is equal to, you know, the u and z transformation is the z upon z minus 1 mod z is greater than 1. This is the z transformation of the unit impulse function. Okay, so if the question came like a u n minus 5, find the z transformation of the u n minus 5. Okay, then how to solve this numerical? Like you simple said that this is the z power minus 5. Okay, then this is the xz. Xz mean you will find out the u and z transformation is the xz, u n minus 10, z transformation is the z power minus 10, that is the xz. So you know the z transformation of the un, that is the z upon z minus 1. Here that is equal to the z upon z minus 1. So here you can write down the value of the xz, that is the z minus 10, z upon z minus 1. So simple, you will say that it is the z power minus 9 upon z minus 1 mod z is greater than 1. This is the ROC. So this is the question basically, how to solve the numerical of the time shifting property basically. Okay, so simply you will say that there is a delay of 5 unit, that is z minus 5 xz. If there is a delay of 10 unit, you can say that the z minus 10 xz, simply xz value is this one. This is the z transformation of the u, and simple put the value here, z upon z minus 1 9. Otherwise without using the properties, if you are solving this kind of numerical, it will goes to lengthy like a 1 or 2 pages. Okay, so what is the main advantage of using this property? You will solve the numerical within the like a 2 or 3 steps only. Okay, otherwise it will take a lengthy. You will solve the numericals with the 2 or uh, it will no, this numerical, if you will solve without using the help of properties, it will take up to the 1 or 2 pages numerical. Okay, lengthy, it will become lengthy. Okay, so any doubt regarding this time shifting property? It is clear to everyone?
Yes, sir.
Okay, so I think we will move on the next property. That is the that we are having a time reversal property. Okay, next one property is the time reversal property.
हेलो सर।
हाँ जी बेटा।
सर लास्ट लाइन कुछ थोड़ा रिपीट कर दीजिएगा।
और दिस वन?
यस सर, वहां से।
Okay. What is the time shifting property basically? Means again I am explaining you that what is the time shifting property. If you are having a xn, okay, then means you know the z transformation of the xn basically. Okay, so wait. Again I am explaining you the what is the property of the time shifting property. If you are having a xn discrete time signal and its z transformation is given by the xz. Okay, means if you are having a xn and its z transformation is the xz. Okay, then if what is time shifting property says that if there is a delay in the signal, okay, you know the xn signal, its z transformation is the xz. But if there is a delay or advance in this signal, okay, delay means negative, advance means positive. Okay, if there is a delay or advance in that signal, okay, then you will simple say that if there is a delay of 10 units, simple write down z power minus 10 and z transformation of the xn. Okay, this is the time shifting property. Again I am repeating, you are having xn, you know the z transformation of xn is the xz. Okay, but the question came in the examination like you have to find out delayed version, z transformation of its delayed version. Then you simply say that this is the z power minus 10 xz. How many samples delay means how many samples of delay are present in the input? You simple write down z minus 10 and xz means the z transformation of the xn is the xz. I have given you the example here, like if you are having a, I have given you the quoted here the two examples. Okay, first example I have quoted here that if you are having xn is equal to un. Okay, you can simply say that the z transformation of un is the xz, that is the z upon z minus 1. Okay, but in the question, in the examination, the examiner asked a question that you have to find out the z transformation of un minus 10. Okay, so how to solve this numerical means you know that un is the standard signal, it is the unit step signal, and its z transformation is the z upon z minus 1. But if the question came in the examination that un minus 10, or the question came like un minus 100, find the z transformation of this signal, then you will simply say that we will apply the time shifting property. Means with the help of time shifting property, we will write down here how many delays are there. 100 sample, it is the minus 100, and you may write down the xz. Okay, xz is, what is the xz here? Xz is the z transformation of un. Okay, un z transformation is the z upon z minus 1. So here you will write down z minus 100.
Sir,
Z
you are
upon,
not audible, sir.
uh, my voice is not audible to
No,
everyone.
sir.
Yes, sir. Audible, sir.
Okay, Nishikant, I think there is the network issue on your side. Okay. Hello. Voice is audible to everyone.
Yes, sir.
Yes, sir.
Okay, beta. Okay.
No, sir.
So simply you will write down the answer of this question is the z minus 99
Sir, you are
upon
still not
z
audible.
minus 1. Again, I am saying that Nishikant, there is a network issue on your side.
सर
Okay,
बोल
okay,
दिया सर
okay, okay. So
थैंक
if the question came like here it is the xn plus 10, then if there is a delay means here you are having a negative sign, then on the z transformation it is the negative sign. But if you are having a positive sign here on the signal side, then on the z transformation side it is also a positive sign. Okay, means xn is equal to un, then this transformation, if the question is xn plus 100, okay, then this is the positive power of 100 xz, then this will become the z 101 z upon z minus 1. Okay, means if you are having a delay version means negative side in the input side, then in the z transformation side it will become a negative power. But if you are having a positive sign, then on the like a z transformation side you have to give the positive sign. Okay, so this is the time shifting property, and on the basis I will kindly answer me if you are having a question like delta, you know that delta and z transformation is the delta and z transformation is the 1, and if we will find out delta n minus 10, its z transformation is the z minus 10 z transformation of delta n. This is equal to the 1, so answer is the z minus 10. Okay, this thing is clear to everyone, I think. Okay, if you are having question delta n minus n plus 5, okay, then its z transformation is the z5. Okay, z transformation of delta n, okay, z transformation of delta n is the 1. Okay, because this is 1, So its answer is the z power 5. Okay. If you are having a delta n minus k, its z transformation is the z minus k. If you are having delta n plus k, its z transformation is the zk. Okay. So this is the properties of the time shifting properties in the delta function. Previously, we have applied the time shifting properties in the unit step function. Okay. So this is the properties of time shifting property in the delta function. So kindly, so moving toward the next property, that is the time reversal property of the Z transformation. So I think two properties, time shifting properties, scaling properties is clear to all of you. And next one property, that is the we are having a time reversal property. Okay, we are having a time reversal property. Okay, so what is the time reversal property is saying? Means if you are having a a xn and its z transformation is given by the xz. Okay, if you are having a xn and you know that the xn z transformation is the xz, but in the examination they may ask about x minus n, then what you will do, you will simply replace z by z minus 1 in xz equation. Okay, simply replace the z minus 1 in the xz equation. I will give you the one example of this time reversal property. From that you will able to understand the what is the time reversal property. Okay, so like if we are having a un and its z transformation is given by z upon z minus 1 and ROC is the mod z is greater than 1. We know this is the standard signal. Un is the unit step signal. This is the standard signal. But if the question came like u minus n, find the z transformation of u minus n. How to solve the values of u minus n? So simply you will write down the first step, this one. Un yet transformation is z upon z minus 1. This one. You simple say that for u minus n, we will simply replace z by z minus 1 in the above equation. Okay, by using the time reversal property, because this is the time reversal property. Okay, so simply replace z by z minus 1 in the above equation. So you may write down u minus n is the z minus 1, z minus 1 minus 1, z in the ROC z minus 1 greater than 1. Okay, so if you will write down, solve this equation. Okay, you may write down this as the z minus 1 is the 1 upon z. This is the 1 upon z. This is also 1 upon z. 1 minus z upon z. Okay, so simple, you may cancel out this z with this one. It is the 1 upon 1 minus z. Okay, xz is equal to 1 upon 1 minus z. Again, if you will solve this and mod z is lesser than 1, because this is the z inverse 1 upon z. Take the z across the right side, this is will become the z minus 1. So ROC is also changing and xz is the your xz is equal to 1 upon 1 minus z. Okay, so this is the z transformation of the u minus n. Okay, any doubt to any student regarding this numerical? It is clear to everyone how to apply the time reversal property, or should I repeat?
Sir, repeat, sir.
Okay, time reversal property is saying that you are having a xn you know that the z transformation of xn is the xz. Okay, but if you have to find out the x minus n, time reversal properties say that x and z transformation is the xz, then x minus n means its mirror image. Okay, its mirror image or its folded signal. Okay, x minus n is the folded signal or mirror image of xn. Its z transformation is same as that of xz. Simply you must replace the z by the z minus 1. In the xz you simply replaced by the z upon z minus 1. Okay, so I have taken the example u and z transformation is given by z upon z minus 1 mod z is greater than 1. But examiner asks you the question that find the find z transformation of u minus n, mirror image of the un. Okay, in that case you will simply say that we are having, this is the standard signal, un z transformation is the z upon z minus 1 mod z is greater than 1. You simple say that the for the u minus n its mirror image, we will simply replace z by z minus 1. Okay, means जहां जहां पे z है वहां पे क्या आ जाएगा z minus 1. Okay, I have written here z minus 1 upon z minus 1 minus 1, and this is also ROC also, this is the z minus 1 is greater than 1. Okay, so simple, you simplified this equation, you will getting xz is equal to 1 upon 1 minus z, and ROC is the mod z is lesser than 1, means interior part of the circle of radius 1. Okay, so any doubt regarding this time reversal property?
No, sir.
सर इसका फाइनल आरओसी इंटीरियर ऑफ द सर्कल आएगा कि एक्सटीरियर ऑफ द सर्कल?
I will explain you. Okay, if you are having a mod z is greater than 1, okay, its meaning is the, it's what is the meaning of mod z is greater than 1? Its meaning that is the exterior part of the circle of radius 1. When it mod z is greater than 1, that means this is the, this is over ROC, that is the exterior part of the circle of radius 1. Okay, this is the ROC basically. Okay, we are having, this is the ROC for this one, that if you are having mod z is greater than 1, that is the exterior part of the circle of radius 1. But if you are having a like a second one, we are having a mod z if you are having mod z is lesser than 1, second case, this is the first case. Okay, first one, if you are having, that is the anterior part of the circle of radius 1. Okay, this is our z plane, that is the anterior part of the circle, this is the anterior part. Okay, this one is the exterior part. Okay, this one is for the causal signal, this one is for the anti-causal signal, this is for the right hand side sequence, this is for the left hand side sequence. Okay, so try to cram these terms. If mod z is greater than 1, this is the exterior part of the circle of radius 1, and it is for the causal sequence. Causal means right hand side sequence. And if you are having mod z is lesser than 1, that means anterior part of the circle of radius 1, that is for the anti-causal sequence, and it is a left hand side sequence. Okay, students, so this is the time reversal property. Okay,
सर आपने इसमें लिखा ना जब u माइनस एन इज इक्वल टू z इनवर्स अपॉन z इनवर्स माइनस 1, उस केस में आपने लिखा मॉड ऑफ z इनवर्स ग्रेटर देन 1, दैट मीन एक्सटीरियर ऑफ द सर्कल. फिर जब आपने
I am
लास्ट
explaining you the ROC again. Okay, I am saying that ki, okay, you are having a confusion at that point. I am saying that u and z transformation is the z upon z minus 1, and ROC is the mod z is greater than 1. For the u minus n, we are having a z transformation z minus 1, z minus 1, 1, This is the ROC is also Z minus 1 greater than 1. Now simplify this equation. This is the 1 upon Z minus 1. Take the LCM. This is also 1 upon Z is greater than 1. Okay. So try to move this Z on the right hand side. Okay. This is the 1 greater than Z. Okay. So we will write down Z. Okay. So this side along the what is the XZ? This is the 1 upon Z. 1, take the LCM in the denominator, that is the 1 minus Z upon Z. So cancel out this Z with this one. You are left with the 1 upon 1 minus Z, and mod Z is lesser than 1. Now it is clear,
Yes, sir.
Prachi?
Yes, sir.
Okay. So you have to move the mod Z along the left hand side. Okay.
Okay,
Don't
sir.
you can't say that the Z minus 1 is greater than 1. It's ROC because this is the 1 upon Z. You have to change it into the 1 upon Z is greater than 1, and take the Z, move the Z along the right side, then see the equation then. Okay.
Yes, sir.
Any doubt to any student regarding the time reversal property? It is clear to everyone?
Yes, sir.
Yes, sir.
Okay. So last one property we are having, that is the like a differentiation in Z domain. Okay. So last property, today's lecture last property, actually it is not the last property. We are left with the 3 or 4 properties, I think. Okay. In the next lecture, we will complete all the properties of the Z transformation. And again and again, I am saying that these properties are very important from the examination point of view, because you will solve the question or the numericals of the Z transformation if you understand these properties. Okay. So last property, today we will discuss the last property, that is the differentiation property. Differentiation property of Z transformation. What is the meaning of this differentiation property? From the name, it is clear that we have to do the differentiation. Okay. So from on which side we have to do the differentiation? So first of all, try to understand this property. If X and Z transformation is the XZ, okay, means you are having a XN, and you know that the Z transformation of the XN is the XZ, okay. But the examiner in the exam, they ask the question in this way, that find the Z transformation of the NXN. Okay, they have multiplied one more N with the XN. So then you can say that then according to the differentiation property, the differentiation of this kind of signal NXN, that is equal to the minus Z d by d by dz of xz. Okay, so you have to differentiate xz with respect to z, and here outside we are having a negative sign also. Okay, so I am explaining you this again with the help of the one more numerical. I will explain you this property with the help of numerical. Like you are having a un. Okay, un, the z transformation of the un, you know that z upon z minus 1, and mod z is greater than 1. This is the basically z transformation of the un. Okay, now if the examiner asks you the question that find the z transformation of the nun, okay, then how you will, question came like this one in the examination, find the z transformation of nun. You simply say that z transformation of un is this one, and by applying the differentiation property, or by using the differentiation property, you can simply say that its z transformation is equal to the minus z. here we have written the minus z and differentiation of with respect to z of z upon z minus 1. You have to do the differentiation of z upon z minus 1 with respect to z. Okay, when you will differentiate this signal, okay, then you will find out the z transformation of this signal. Then you will able to find out the z transformation of the u minus n. Okay, so the differentiation of the u minus n in this case you have to find out. So student, this is the second tutorial you have to do by your own. There you will find out the differentiation of the n u n question numerical. So I think this is over from my side.